Okay, conditions for parallelograms. In this case, we're going to kind of go the other direction. If we have a quadrilateral, how can we prove that it is a parallelogram? Well, first off, recall that a parallelogram has the following properties. Opposite sides are parallel, which is the definition. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. We can use each of those properties to prove that a given quadrilateral is a parallelogram. One option we have that does not come from the properties is that if I have a quadrilateral where I have one pair of opposite sides that is both congruent and parallel, then the quadrilateral is a parallelogram. So that's one option I have. I can also use the converses from the theorems, the properties from the previous section to show that the quadrilateral is a parallelogram. So if opposite sides are congruent, then I have a parallelogram. If opposite angles are congruent, I have a parallelogram. If consecutive angles are supplementary, I have a parallelogram. If diagonals bisect each other, I have a parallelogram. So in each of those cases, if I have a quadrilateral where any of those things are true, then that quadrilateral is a parallelogram. Now, special parallelograms. So again, this is our rectangle, our rhombus, and our square. We can look at the definitions we had from the last section to prove that a quadrilateral is a special parallelogram, but we do also have some shortcuts we can use. So for each of these shortcuts, though, you have to start off with knowing that the quadrilateral is a parallelogram. So first you have to prove it's a parallelogram, then you can use one of these. So if I want to prove that a parallelogram is a rectangle, then I can pick either, if one angle is a right angle, then it's going to be a rectangle. If the diagonals are congruent, then I'm going to have a rectangle. And again, that gets back to what I talked about last section of checking for square. If you have a parallelogram, if you know that if the opposite sides are congruent, and you can prove the diagonals are congruent, then you've proved that you have right angles. So you've checked for square. That's kind of how that comes into play. Now, if I want to prove a parallelogram is a rhombus, then if a pair of consecutive sides is congruent, if two sides that are next to each other are congruent, okay, well again, it goes back to opposite sides being congruent. Well, if two sides that are next to each other are congruent, then the sides opposite those are congruent, and so all the sides are congruent, so I have a rhombus. And then if my diagonals are perpendicular, then I have a rhombus. Or if I have one diagonal that bisects a pair of opposite angles. Okay, so if I have a parallelogram and one diagonal bisects a pair of opposite angles, then I have a rhombus. Now, if I want to prove that a quadrilateral is a square, I have to basically prove that it is both a rectangle and a rhombus. So I have to go through basically both processes there. Okay? So we're going to look at different ways to do this when we get to class, as far as both formal proofs, kind of informal proofs, that sort of thing.